Imagine looking up at the night sky and noticing not one, but two unfamiliar lights wandering through the stars. They are not like the planets, which follow steady paths, and they are not like the countless stars that remain fixed in their ancient constellations. These are visitors, glowing softly, drifting steadily, as though the universe itself decided to set a rare scene before our eyes. Together, they form a duet that feels less like chance and more like choreography. Scientists describe 3I Atlas as a needle of light, slender, purposeful, almost deliberate. Its nucleus may be only a few kilometers across, yet it radiates mystery far larger than its size. Swan R2 is the opposite, expansive, dramatic, a luminous veil stretching across the sky. The stars above are steady points. The comet, by contrast, feels alive, its glow breathing, its coma expanding, its color pulsing with a faint radiance. You lean closer to the eyepiece and notice that the green is not harsh but gentle. It does not flash or flicker, it soothes. It is the kind of green found in quiet forests, in spring leaves lit by the sun, in ocean waves caught at twilight. A color that feels both natural and otherworldly at once. For ancient people, such a sight might have been a divine omen. Green was the color of growth, of renewal, of fertility. To see it blazing in the sky might have been read as a promise or a warning. In Egypt, green was linked with Osiris, the god of rebirth. In China, jade green symbolized immortality. To watch Atlas glowing emerald above the horizon is to stand in continuity with those old myths, to feel the same awe that once filled entire civilizations when comets appeared unexpectedly. But modern science adds its own poetry. The molecules causing this glow are fragile, easily broken by sunlight. That means the green light we see is not static, it is constantly being renewed, a process of destruction and rebirth happening in real time. Every photon of green is a farewell, a molecule splitting, transforming, disappearing. What you see glowing is already gone, even as more take its place. It is a performance of impermanence, written across millions of kilometers of space. Astronomers debated whether the glow might reveal something deeper. Could the relative strength of cyanogen point to a unique birthplace, a star system with different chemistry from our own? Could the carbon signatures hint at organic precursors, molecules that might one day seed life elsewhere? Questions multiplied, even as answers lagged. The comet glowed, and humans wondered. And wonder, too, is a kind of science. The James Webb Space Telescope turned its instruments toward Atlas and confirmed the dominance of carbon dioxide in its composition, with little water. The green, then, became not only a curiosity, but a clue, part of a broader puzzle of chemistry that seemed foreign. Some even speculated that the glow could be intentional, a signal designed to be visible, a kind of beacon written in wavelengths our eyes and instruments could not ignore. The idea remained fringe, unproven, yet alluring. After all, if you were to craft a message in the heavens, what better medium than a color no one could miss? But for those who step outside and look, the theories do not matter. What matters is the feeling. Standing under the autumn sky, you see a faint green smudge, delicate yet undeniable. And for a moment, the world feels larger, stranger, filled with possibilities. The comet is not just ice and dust. It is a mirror reflecting your own imagination. Its green glow says, look closer, dream wider. Remember that the universe is not exhausted of surprises. You might think of it as a lantern carried through the dark. For millions of years, Atlas wandered unseen, unlit. Only when it neared our sun did it ignite with emerald fire, as if announcing itself. It reminds us that journeys often reveal their meaning only near the end, when light finally falls upon them. Perhaps your own life has moments like that, long stretches of darkness, then sudden illumination, colors blooming where you did not expect. In sleep, such imagery lingers. As you close your eyes, you might imagine drifting alongside Atlas, watching molecules erupt into green around you. It would be quiet, utterly silent but glowing, radiant, alive. You would float in a cocoon of emerald light, carried inward toward the sun, knowing you are part of a story much greater than yourself. The green glow of Atlas is more than chemistry. It is more than speculation. It is an invitation to see, to feel, to wonder. It tells us that the universe writes beauty even in the smallest particles, that photons born of broken molecules can create something worth remembering. And as you drift deeper into rest, let that color remain with you, a gentle green, timeless, endless, shimmering softly in the quiet sky. October 3rd, 2025. On this date, Mars will keep an appointment written in the sky for millions of years. The red planet, circling quietly on its long orbit, happens to drift within 30 million kilometers of the interstellar visitor known as 3I Atlas. In the vastness of space, such a distance is still immense, yet for astronomy, it is tantalizingly close. It is close enough for our robotic emissaries, orbiting Mars, to turn their instruments outward, to become witnesses on our behalf. Standing beneath them, one feels as though watching a cosmic contrast play out in real-time precision and delicacy beside extravagance and spectacle. But it is not just their appearance that puzzles. Their chemistry, too, raises questions. 3I Atlas glows green, a tint produced by diatomic carbon and cyanogen molecules excited by sunlight. Natural enough, perhaps, but its consistency and intensity have startled experts. For a brief window of time, Mars itself becomes humanity's forward observer. Imagine the scene. Mars is silent, its deserts stretching beneath a cold, thin sky. Above its canyons and volcanoes, a fleet of machines circles endlessly NASA's Mars Reconnaissance Orbiter, the European Space Agency's ExoMars Tracegas Orbiter, the veteran Mars Express. Their cameras, spectrometers, and sensors were built to study Martian dust storms, polar ice caps, and atmospheric chemistry. Yet for this one occasion, they will swivel outward, pointing not at their host planet, but at a traveler from beyond the stars. Their lenses will catch photons reflected from Atlas's coma, photons that began their journey only seconds before. And through them, we will see what Earth cannot. For Earth's ground-based telescopes will already be struggling. Solar glare will soon swallow Atlas, hiding it in brilliance. But from Mars's different vantage point, geometry grants a clearer angle. It is as if the universe has placed a cosmic relay station in orbit around another planet, giving us a second chance to watch. From that red perch, the story continues. The science goals are many. Cameras will attempt to record the coma's structure, the halo of gas and dust expanding around the nucleus. By analyzing how sunlight scatters through this haze, researchers can estimate the size distribution of dust grains, whether fine powder or larger fragments dominate. Spectrometers will look for fingerprints of molecules, carbon dioxide, cyanogen, diatomic carbon, searching for changes as the comet heats under the sun's rays. If the chemistry shifts, Mars may be the only place where we see it unfold in real time. Even more intriguing is the ion tail. When the solar wind streams past the comet, it sweeps charged particles into a luminous ribbon pointing away from the Sunday from Earth. The tail may be lost in glare. From Mars, it could reveal delicate structures, bends, and disconnections that trace the invisible magnetic fields of interplanetary space. Each curve, each shimmer, tells of plasma interactions on a scale far larger than planets themselves. To see it from Mars is to see space weather written across millions of kilometers. And yet, for all its promise, the encounter will be delicate. 30 million kilometers is still far, far away. To the cameras on Mars orbiters, Atlas will appear as little more than a point of light, perhaps a faint smudge at best. Instruments must work at their limits. Data must be carefully processed, stacked, enhanced. There will be no heroic close-ups, no detailed photographs of a nucleus. Instead, the value lies in precision, subtle changes in brightness, spectral lines measured against background noise, small hints that accumulate into meaning. The timing adds both excitement and tension. As Atlas nears its perihelion later in October, solar heating will intensify. Outbursts may occur, jets of gas and dust erupting from its surface. If such an outburst happens near October 3rd, Mars orbiters may be the only instruments positioned to record it. But mission planners face challenges. These spacecraft were never designed for deep space targets. Their pointing systems, communication windows, and memory allocations must be carefully adjusted. Commands must be uploaded in advance, since radio signals between Earth and Mars take minutes to cross. There will be no real-time control, only carefully planned sequences executed faithfully by machines millions of kilometers away. It is easy to forget how remarkable this island, a comet born beyond the stars, swings through our solar system. A planet that has never known human life plays host to a fleet of robotic observers. And from Earth, across that gulf, we coordinated all tiny signals traveling between planets, telling machines to look outward at just the right time. It is a choreography spanning worlds, fragile and beautiful. Some imagine even more. What if Atlas itself notices Mars? What if the green visitor, with its nickel without iron and its peculiar chemistry, passes near enough to detect the presence of our machines? Could it see the glint of metal orbiting the red planet? Could it hear the faint electromagnetic hum of our instruments? Such speculation is fanciful, yet it adds a dreamlike layer. For a moment, we can imagine Mars not only as our witness, but as a participant in a silent dialogue across space. Swan R2, meanwhile, brightened so rapidly upon its discovery that its composition must be unusual, unlike typical comets of the Oort cloud. It is as if each visitor carries a dialect of chemistry written in a language we have only begun to understand. And then there is the timing. 3. Atlas is scheduled for its closest approach to the Sun on October 29, 2025. When the data arrives, it will come slowly in bursts. Mars orbiters must downlink their observations during scheduled windows, sometimes days or weeks after the encounter. Scientists on Earth will wait impatiently, refreshing dashboards, passing raw numbers into graphs, graphs into meaning. In university labs and space agency offices, they will lean closer to the first processed images, looking for hints of structure, for colors that tell of molecules, for curves that reveal tail geometry. Each pixel will matter, each faint smear of light will be treasured. And you, lying in bed tonight, can imagine that anticipation. Imagine knowing that millions of kilometers away, machines are watching a visitor on your behalf. Imagine that in those moments, Mars itself becomes your eyes, your ears, your presence in a cosmic encounter. The red planet has long been a symbol of war in myth, but tonight it plays the role of quiet witness, an observatory circling in silence. If Mars could speak, perhaps it would describe Atlas as a green flame drifting across its sky. Perhaps it would say, "I have seen storms of dust, I have seen seasons of frost, but never have I seen a messenger from beyond." Perhaps Mars would marvel with us. As Atlas sweeps past, it will not linger. In hours, the geometry changes, the visitor moves on, the instruments turn back toward their primary tasks. But the data will remain. And in that data, pieces of a story will emerge: how the comet brightened, how it released gases, how its tail shimmered. tiny pieces of truth collected by machines circling a planet we have yet to set foot on. The Mars encounter is not a spectacle for human eyes. It is a quiet passing, recorded in numbers, in spectra, in graphs. But it is also a reminder of how far our reach has grown. We have placed sentinels around other worlds, and they now help us read the stories of stars. The universe does not wait for us. Yet in moments like this, it seems to pause, allowing us a glimpse of its mysteries. So, as you rest tonight, let your mind wander to Mars. Picture its silent deserts, its orbiting machines, its skies brushed briefly by a green visitor. Picture data flowing homeward across the void, carrying whispers of an interstellar story. And let yourself feel for a moment the wonder of being alive at the exact time when two cosmic wanderers cross paths with our own small system, and we are here to notice. While 3I Atlas dazzles us with its interstellar mystery, another traveler quietly steals the stage. This one is not foreign, not alien to our solar system, but its arrival is no less dramatic. It is Comet C 2025 R2, better known as Swan R2, named after the Solar Wind Anisotropies instrument, or SWAN, aboard the SOHO spacecraft that first revealed its presence. Where Atlas appears as a green needle of light, Swan R2 blooms like a luminous veil, wide and extravagant, sweeping across the evening skies. Its discovery was a story of patience and sharp eyes. An amateur astronomer named Vladimir Bezugli spent long hours poring over SWAN images, searching for subtle variations. On September 11, 2025, he noticed an anomaly, an unexpected brightening, a hint of a tail forming in the glare near the Sunday. He reported his finding, and soon the world of astronomy confirmed it. A new comet had arrived. It was not faint. Even at discovery, it was already bright enough for binoculars, already growing, already magnificent. By mid-September, Swan R2 had become a favorite target for stargazers. Photography forums filled with long exposure images of its sprawling tail, a ribbon of light stretching degrees across the sky. To the naked eye, in dark places far from cities, it shimmered faintly, just at the edge of vision. Through modest binoculars, it revealed itself more clearly, its head glowing, its tail sweeping upward, like a brushstroke against twilight. Amateur astronomers, children, families, many who had never seen a comet before looked up in awe. For them, this was no abstract data set. It was a living wonder. The comet's path told its own story. Unlike Atlas, which carved a hyperbolic trajectory from beyond the stars, Swan R2 followed a closed ellipse. It had slumbered in the Oort cloud, that icy reservoir encasing our solar system, for perhaps millions of years. Some small perturbation, a gravitational nudge from a passing star, or the subtle tug of galactic tides sent it inward. Swan R2 reached its perihelion earlier, on September 12th, but its closest approach to Earth will occur on October 21st, just 8 days before Atlas brushes past the Sunday. Two objects from two utterly different origins, both reaching climaxes in their journeys within the span of a single month. The mathematics of orbital mechanics say this is rare, but human imagination whispers that perhaps rare does not mean accidental. Consider for a moment the blind spot of our instruments. As it drew closer to the sun, solar heat began its alchemy, turning ancient ice into streams of gas and dust, painting a display across the sky. On September 12th, Swan R2 reached its perihelion, its closest approach to the sun, at half an astronomical unit. The encounter was fiery. Solar radiation vaporized its surface ices, releasing hydrogen, carbon dioxide, cyanogen, and dust into space. The coma swelled to enormous proportions, its tail stretching millions of kilometers. But unlike many comets that peak and fade quickly, Swan R2 continued to brighten even after perihelion, its display growing more vivid as it prepared to pass near Earth. October 21st marked its closest approach to our planet, within 0.27 astronomical units, about 40 million kilometers. In cosmic terms, it skimmed by. Not dangerous, not threatening, but close enough to capture imaginations across the globe. For many in the southern hemisphere, the view was breathtaking. A comet as wide as several full moons in the sky, its tail arcing across constellations. Planetariums used it as a teaching moment, reminding audiences of how comets carry the frozen ingredients of solar systems. Schools organized stargazing nights. News outlets called it the comet of the season. To scientists, Swan R2 was more than a spectacle. It was a chance to study a long-period comet at close range. Its brightening curve defied expectations, rising faster than typical models predicted. Its tail showed structures of unusual complexity, streamers, disconnections, faint knots where solar magnetic fields sculpted the gas. Spectrographs revealed a composition rich in volatiles, but in patterns slightly askew from known comets. It was as though Swan R2 had grown up in the same family as our solar system's icy bodies, yet carried its own dialect of chemistry, shaped by centuries in the Oort cloud. Imagine for a moment what it means for such a body to arrive here. The Oort cloud lies far beyond Neptune, a realm so distant that sunlight is barely more than starlight. There, comets remain frozen, unchanged, like fossils preserved in ice. When one is nudged inward, it begins a journey that can take centuries. Swan R2's voyage may have begun long before human civilization rose, long before pyramids, before writing, before firelight in caves. While generations of humans lived and died, the comet drifted inward, silent, waiting, and only now, in this October, it reveals itself in our skies. From a distance, Swan R2 is enormous. Its coma, the sphere of gas and dust around its nucleus, can span hundreds of thousands of kilometers. Its tail may stretch millions. And yet, at the heart of it all, the nucleus is small, perhaps only a few kilometers across, a dark and icy core driving all this brilliance. That contrast is humbling, something so small, creating beauty on such a scale. It is a reminder that light often comes from the most unlikely places. The mythic mind, too, finds resonance here. In cultures worldwide, great comets have been seen as heralds of change. The sudden blaze in the sky seemed too dramatic to be meaningless. Swan R2, with its sprawling majesty, fits that archetype perfectly. If ancient eyes had seen it, they might have proclaimed new kings or feared catastrophe. Today, we have equations, sublimation curves, orbital mechanics, yet still, when we stand under its glow, the feeling is the same: awe, humility, a sense that we are part of a larger story written in the heavens. And then there is the coincidence that Swan R2 arrives just as Atlas does, one local, one foreign, one vast and bright, one small and green. Their convergence invites comparison, as though nature itself has staged a controlled experiment. Two comets, under similar solar heat, showing us the difference between origins. For scientists, this is a priceless chance to study how environment shapes destiny. For poets, it is a duet. For dreamers, it is a sign. As you rest tonight, let yourself imagine standing under Swan R2's tail. Imagine it stretching above you, silent, luminous, fragile. Imagine its particles falling away, scattering into the solar wind, some perhaps drifting toward Earth in faint meteor showers. Every glowing molecule has traveled from deep time, now burning briefly before vanishing. You are part of its audience, one of the few generations in all of history who will see it. Swan R2 reminds us that the cosmos does not forget to astonish. Even in an age of satellites and algorithms, it sends us spectacles that no photograph can capture fully, that must be felt under the night sky. Its brightness will fade, its tail will thin, its path will carry it outward again. As both comets sink deeper into solar glare, our telescopes will be rendered useless, blinded by the light of the very star they approach. During the most critical days, the period when they might reveal their deepest secrets, we will see nothing. It is as though a curtain falls precisely when the drama reaches its peak. But the memory of its appearance, the new giant of October skies, will remain. And perhaps, as you drift into sleep, you will carry with you the image of that luminous brushstroke painted briefly across the canvas of time. Every comet is, by definition, a natural body at least. That is what our textbooks tell us. They are ice and dust, relics of early formation, fragments of the solar system's beginnings. And yet, when something defies expectation, the human mind begins to wonder, could what looks natural actually be artificial? Could there be machines so advanced that they hide in plain sight, wearing the disguise of comets? This is where speculation drifts like a quiet tide. Some imagine propulsion systems, plasma engines hidden within the streaming tails. A natural comet brightens and sheds gas as the sun's heat stirs its frozen heart. But what if some of that outgassing were not random, but controlled? A plasma drive ejecting ionized gases at carefully chosen angles would produce thrust, while appearing, at first glance, like ordinary sublimation. Our telescopes would see only the glow, the shimmer, the tail. We would record acceleration as if caused by uneven melting, yet in truth, it could be the whisper of an engine firing silently in the dark. Others turn to electromagnetic fields. Comets naturally develop ion tails as the solar wind sweeps their gases into ribbons. Magnetic interactions sculpt those tails into curves and disconnections. But what if those same signatures were being shaped intentionally? Imagine coils buried within a nucleus, generating controlled magnetic fields. To us, it would look like natural behavior, charged particles flowing, solar wind deflected. Yet, hidden within, might be patterns too precise, geometries too deliberate. The difference between chaos and choreography is often subtle, and in the vacuum of space, subtlety might be the perfect camouflage. Astronomers search for anomalies. They look for deviations from Kepler's laws, small changes in orbit that cannot be explained by gravity alone. They watch brightness curves, expecting the irregular rhythm of sublimating ices. They listen with radio telescopes for coherent signals, for emissions that carry structure. So far, they find only nature. Atlas follows its hyperbola faithfully. Swan R2 shines as a comet should. No accelerations out of place, no artificial signals. But the absence of evidence is not always evidence of absence. Perhaps advanced technologies, if they exist, do not announce themselves in ways we expect. Perhaps they operate within natural laws so gracefully that we mistake design for chance. It is not the first time humans have asked this. When Oumuamua swept past in 2017, some noted its odd acceleration, its strange shape, its lack of a visible tail. A few dared to suggest it might be a probe. The idea was controversial, but it opened the door. Borisov followed in 2019, more comet-like, more ordinary. Then came Atlas, with its nickel without iron, its emerald glow. With Swan R2 arriving at the same time, speculation flared once again. Was this choreography? Was this technology? Or simply the dice of chance rolled in our presence? The invisible machine theory carries a haunting beauty. Imagine civilizations so advanced they no longer build shiny spacecraft, but sculpt comets into vessels. A machine disguised as ice and dust would never draw suspicion. It would move among natural bodies unnoticed, blending with the crowd. It could harvest energy from solar wind, communicate through plasma interactions, navigate by subtle magnetic shifts. To our instruments, it would look like nothing more than a comet doing what comets do. Only its purpose would be different. And perhaps that is the unsettling part, that we may not even know what to look for. Our expectations of machines are based on our own inventions, engines that roar, electronics that radiate, heat signatures that glow. But what if technology, thousands or millions of years older, does not leave such fingerprints? What if it leaves only silence, only the faint green glow of cyanogen, only the whisper of nickel lines in a spectrum? Could we even recognize it, or would we catalogue it as anomaly and move on? Still, there is comfort in the conservatism of science. NASA and ESA remind us that every anomaly so far has found natural explanation. Plasma engines remain hypothetical, magnetic shields remain fantasy, and some cannot help but ask, what if that timing is not mere coincidence? What if something, or someone, does not want us watching? Yet for all the questions, there is also serenity in their presence. Imagine stepping outside and lifting your gaze upward, knowing that above your head, across millions of kilometers of space, two travelers are converging. Their paths were written long before humanity ever existed, yet they now intersect during our brief moment of observation. What we see outgassing, tails, spectra, fits the patterns of nature, even if at the edges. To assume technology is to leap further than the data allows, and yet to wonder is human. Imagine lying under the October sky. Above you, Swan R2 spreads its brilliant veil. Atlas glows faintly green nearby. Both tails stream away from the sun, as physics dictates. And yet, you cannot help but think, what if those tails are not only physics, but intent? What if you are watching, not just sublimation, but navigation? The thought lingers like a dream, too strange to be believed, too elegant to dismiss entirely. Speculative thinkers have offered models. A comet turned into a vessel might house cavities lined with superconductors, capturing solar energy. Its tail might serve as a communication antenna, modulating particles as they stream outward. Its coma could hide sensors, monitoring planetary atmospheres as it passes by. To us, these would look like normal cometary behaviors. To them, they would be tools. And perhaps that is the point: machines, designed not to be seen as machines, but as wanderers of ice. Such ideas can be unsettling, but they can also be calming. If the cosmos does hold invisible machines, then we are not ignored. We are observed, included, part of a network larger than ourselves. Perhaps these comets are not threats, but reminders, gentle taps on the shoulder of humanity, saying, "You are not alone, and your story is only beginning." And so, as you drift into sleep, let your mind play with the possibility. Picture Atlas not only as a fragment of ice, but as a vessel cloaked in dust. Picture Swan R2 not only as a comet, but as a fortress carrying quiet technology. They pass together near the sun, their secrets hidden in plain sight, their voices disguised as silence. To us, they are comets. To themselves, perhaps, they are something more. In the end, science will test every idea. Observations will continue, data will be gathered, theories will be weighed. The most likely answer remains natural chemistry, gravity, coincidence. But as the tails fade, the glow diminishes, and the comets drift away, the questions remain. Could there be machines we cannot see? Could the universe be filled with technologies that choose to appear as nature? The thought is not proof, but it is poetry. And in the space between proof and poetry lies the dream. Let that dream accompany you now. Close your eyes and imagine invisible machines gliding across the void, quiet as comets, luminous as lanterns, timeless as stars. When two travelers appear in the same sky, arriving within weeks of each other, it is tempting to wonder if they share a purpose. One, small and swift, green as a lantern. The other, vast and sprawling, a canvas of dust and gas stretched across constellations. Atlas and Swan R, two different in origin, different in scale, yet together in time. Could they be more than coincidence? Could they be partners in a mission that stretches beyond human comprehension? Science offers restraint. The statistics are clear coincidences. Even rare ones do happen. Two comets in the same season, even from different origins, may simply be the universe rolling its dice. Yet human minds lean toward pattern, toward narrative. We see two arrivals and imagine a duet. We ask, what if one is a scout, the other a base? What if one measures, the other records? What if they were never meant to arrive alone? The scout and depot scenario unfolds like a quiet story. Atlas, compact and fast, darts inward from the gulf between stars. Its trajectory is sharp, its chemistry peculiar, its glow steady. A reconnaissance probe, nimble and efficient, carrying data from faraway systems. Swan R2, by contrast, is monumental. Its coma spreads wide, its tail unfurls like a sail. It could serve as a relay, a warehouse, a processing hub. One gathers, the other distributes. One whispers, the other amplifies. In this interpretation, their meeting near the sun is no accident but a rendezvous long prepared. To imagine such coordination is to rewrite the way we see comets. Instead of frozen leftovers, they become tools in a network, an interstellar infrastructure of ice and dust shaped into function. The tails are not just byproducts of sublimation, but signals disguised as natural emission. The comas are not accidents of heat, but shields for hidden operations. It is like hearing two instruments in a vast cosmic symphony briefly harmonize before drifting apart again. The notes are fleeting, but the resonance lingers. Perhaps comets have always carried this role in our imaginations. In ancient times, they were omens, signs of coming change, heralds of endings and beginnings. Today, with all our technology, we might see them as ice, rock, and gas obeying physics. But deep inside, the mythic resonance remains. The sun itself becomes a stage where these roles intersect, providing the energy needed for their exchanges. But even if the truth is natural, the metaphor remains powerful. Atlas and Swan R2 remind us that missions are often shared. A lone traveler can carry knowledge, but paired travelers can weave stories. In science, too, meaning emerges when data from different sources converge. The small and the large, the faint and the brilliant, together they offer perspective. In their coincidence, we are reminded that the cosmos, like life, rarely moves in isolation. Picture October skies, Atlas, faint and green, barely visible to modest telescopes. Swan R2, sprawling and spectacular, visible even to binoculars. 2 points of focus, 2 beacons. If you stand outside, away from city lights, you might catch both in the same evening. You might feel they are speaking, not to each other, but to you. Their timing becomes a conversation, their difference, a harmony. Speculation grows more poetic still. Perhaps they are not only partners, but phases of one design. The scout arrives first, testing conditions, preparing the way. The depot follows, larger, slower, anchoring the mission. Or perhaps they are paired deliberately, a needle of light and a luminous veil, each with complementary strengths. To humans, this pairing is suggestive of cooperation. To the universe, it may be nothing more than orbital mechanics. But to the dreamer, it is a shared mission, written across the stars. Consider how we ourselves act. When humanity explores, we rarely send one vessel alone. Probes go in pairs, fleets in waves. Data requires redundancy. Safety requires backup. If advanced civilizations operate with similar logic, why would they not send multiple couriers, each designed for a role: Atlas for reconnaissance, Swan R2 for logistics? A duet of function, converging in our skies. Still, wonder does not demand proof. To imagine is not to conclude, but to dwell in possibility. Perhaps Atlas and Swan R2 truly are nothing more than icy wanderers, their paths crossing by chance. Even so, their convergence offers a gift. It reminds us of how meaning is created not only by what we know, but by how we interpret. A comet is ice. Two comets together are a story. And there is comfort in stories. They remind us that we are part of something larger, that even coincidences can carry poetry. A green flame and a luminous veil, both drifting toward the sun, both arriving in the same month of the same year. Whether mission or accident, they become symbols of connection between stars, between ideas, between people who gather under the night sky to watch. Close your eyes now and imagine them side by side. Atlas darting ahead, swift and sharp. Swan R2, unfurling behind, vast and radiant. Together, they move in silence, yet their silence feels purposeful, almost like a dialogue spoken in light. If there is a shared mission, it may not be about them at all. It may be about us, about teaching us to look, to wonder, to imagine. For when you gaze upward at two cosmic visitors sharing the sky, you are invited to consider that life itself is a shared mission. We are not solitary wanderers. We are scouts and depots, seekers and keepers, small sparks and great flares. Each of us part of something larger, each of us complementing another. The comets may be silent, but their lesson is clear. Journeys are meant to be shared. So let yourself rest in that thought. The universe has given us a duet this October. Two visitors, two stories, one sky. Whether coincidence or choreography, their presence together is a reminder that we are never truly alone. In the vastness of space, even wanderers find companions. Among all the stories woven around these two visitors, perhaps none is as haunting as the relay hypothesis. It suggests that Atlas and Swan R2 are not just wanderers, but couriers and relays in a network older than we can fathom. One carries, the other transmits. One arrives as a messenger from beyond the stars. The other awakens from the deep cold of our own solar system, together completing an exchange too subtle for us to see directly. Picture Atlas first. Small, green, swift. Its hyperbolic path testifies to an origin beyond our sun's reach, a fragment born in another stellar nursery. For millions of years it drifted through interstellar darkness, silent, patient, unchanged. But perhaps during that time, it gathered more than just frost and dust. Perhaps, locked within its layered ices, it stored information data compressed into structures that endure cosmic radiation and time. When two comets appear together in one season, it feels like the universe has written a story just for us. So let the story unfold slowly, as you close your eyes and drift into rest. Let the faint green of Atlas and the sweeping silver of Swan R2 merge in your mind into a quiet dreamscape. They are not threats, not dangers, but messengers, symbols of how vast the cosmos is, and how brief and wondrous our chance to watch can be. In this telling, Atlas is not only a visitor, but a courier, a tiny capsule carrying a library disguised as ice. Now picture Swan R2, large, luminous, unfurling its tail like a great sail against the twilight sky. Where Atlas is compact, Swan R2 is expansive. Where Atlas races, Swan R2 lingers. Such contrast invites interpretation, one designed for speed, the other for capacity. If Atlas holds the message, Swan R2 might be the amplifier. Its enormous coma and tail could be more than sublimation. They could be collection surfaces, transmitters disguised as gas and dust, In the language of speculation, it becomes a relay station, powered by the sun, broadcasting whatever Atlas delivers. And here the sun itself becomes the third player. Its gravity gathers both comets near at the same time. Its energy bathes them, ignites them, fuels their most dramatic displays. More than a backdrop, the star could serve as the engine of the relay, providing the raw power for data transfer. Some dreamers imagine gravitational lensing, the bending of light by the sun's mass, focusing signals across interstellar distances. Others picture plasma interactions, the solar wind manipulated into streams of information. Whatever the method, the sun becomes not just a star, but a post office, a node in a galactic network. Skeptics shake their heads, pointing out the lack of evidence. No unusual radio signals, no unexplained accelerations, no deviations from natural comet behavior. Science remains grounded. Atlas and Swan R2 behave like comets, even if at the exotic edges of expectation. Yet the relay hypothesis lingers because it offers something data alone cannot: narrative satisfaction. It transforms coincidence into choreography, chance into message. It whispers that we are not merely bystanders, but recipients, standing unknowingly beneath a cosmic handoff. Imagine the scene as though you could see it. Atlas approaches, glowing green, shedding dust, and molecules that shimmer in spectra. Swan R2 waits nearby, its coma swelling like a net cast wide. Between them, invisible flows of energy and particles exchange. Perhaps information is written in patterns of ionization, in rhythms too subtle for our instruments to decode. Perhaps Swan R2 then turns toward the sun, using its brilliant tail as an antenna, transmitting the collected message outward, past the glare, toward some distant receiver across the galaxy. For you lying awake, this imagery is not meant to be literal, but dreamlike. Picture the two comets as dancers on a stage of fire, their motions slow, their gestures deliberate. One bows, offering what it carries. The other rises, lifting the gift toward the sun, where light itself carries it away. It is a ballet of time and distance, of silence and radiance, unseen by most of the world, yet playing out in the heavens above. Even if the relay hypothesis is never proven, its beauty lies in what it reflects back upon us. For we too are creatures who relay. Stories pass from generation to generation. Knowledge is carried like a flame, from one hand to another. Our own radio signals leak into space, a sphere of chatter and music and mathematics expanding at the speed of light. We are already sending messages, whether we intend to or not. To imagine comets doing the same is to imagine that we are part of a conversation larger than ourselves. Consider, too, the timing. Our earliest radio broadcasts are now just over a century old, traveling outward across 100 light years. If another intelligence were listening, those signals might have reached them decades ago. Enough time, perhaps, to send couriers like Atlas, to awaken relays like Swan R2, to coordinate a reply that arrives just as we are ready to notice. The hypothesis stretches possibility, but it also satisfies a deep intuition that the universe does not ignore voices when they rise. And yet, as scientists remind us, the evidence remains ordinary. Sublimation explains the tails. Chemistry explains the glow. Orbits follow gravity's script. The comets may be no more than what they seem: ice, dust, coincidence. But imagination takes the ordinary and makes it extraordinary. The relay hypothesis survives not because of data, but because of longing, the longing to know we are part of a larger dialogue, that our small world matters in the vast conversation of stars. As you drift into sleep, let the imagery linger. Atlas, the messenger, racing inward. Swan R2, the station, luminous and vast. The sun, the power source and amplifier. When you think of discovery, you might imagine a sudden cry of triumph, a scientist leaping to their feet, astonished by what they see. Yet in astronomy, the truth is far quieter. Most discoveries begin not with shouts, but with silence, the silent gaze of instruments spread across deserts, mountaintops, and even the void of space. These machines, like tireless watchers, do not sleep. Their electronic eyes capture photons night after night, patient, steady, indifferent to time. And you, a listener, wondering whether you have just witnessed a cosmic data drop. Whether true or not, the thought is a lullaby of wonder. It reminds you that the sky above is not just scenery. It may be communication, it may be connection, it may be story. And if someday evidence emerges, months or years from now, showing that these visitors carried something more than ice and dust, well, then you will remember October 2025, the month when two comets danced, and you will know that you once lay awake under their light, already imagining the truth. The sun burns with endless fire, 4 million tons of matter transformed into energy every second. It is the heartbeat of our solar system, the lamp that sustains life, the furnace that shapes worlds. But what if, to others, it is more than just a star? What if it is a resource, a fuel station, a harvest field? This is the thought behind the harvest scenario, that Atlas and Swan R2 may not be random visitors at all, but collectors, drawn here by the promise of energy and matter only a star can provide. Imagine standing on Earth as the two comets approach. Atlas appears small, a green flame racing inward. Swan R2 stretches across the sky, luminous and vast. Together they frame the sun as if in orbiting ritual. Their tails shimmer like funnels, pointing not only away from the sun but also outward, as if channeling energy into the void. To our eyes, this is sublimation ices turning to gas pushed by sunlight into streams of light. But to a more imaginative eye, it could be technology hidden in plain sight: magnetic funnels, plasma collectors, resource harvesters, disguised as dust and vapor. The idea is not entirely alien to us. Humanity has long dreamed of Dyson spheres, vast arrays collecting stellar output. We already experiment with solar sails, catching photons for propulsion. On Earth, we build panels that transform sunlight into electricity. Why would civilizations older than ours not scale such ideas upward, using stars themselves as stations? Perhaps comets are part of that infrastructure, mobile collectors that dip into stellar environments, gather energy or exotic particles, and carry them back across interstellar distances. What would they seek? Some point to helium-3, an isotope produced in the sun's furnace, prized as an ideal fuel for fusion reactors. Others imagine rarer forms of matter, particles born in the extreme conditions of stellar coronas, quark-gluon plasmas, magnetic monopoles, exotic materials that we barely understand. If advanced civilizations know how to harvest these, then stars are not only lights in the sky, they are resource fields, industrial sites on galactic scales. In this light, Swan R2's dramatic display takes on new meaning. Its magnificent tail could be more than ice turning to gas. It could be a magnetic funnel, spread wide to catch streams of charged particles, guiding them inward toward hidden processes. Atlas, smaller and more agile, could serve as a surveyor, mapping plasma flows, measuring solar rhythms, identifying optimal collection points. Scout and harvester, needle and net. Together, they enact a ritual older than our species, the gathering of fuel from fire. Skeptics remind us that natural physics explains everything we see. Tails point away from the sun because of solar wind. Brightness rises as volatiles sublimate. No accelerations suggest active maneuvering. No anomalous signals betray hidden machinery. By every measure, these are comets. And yet, the harvest scenario lingers because it mirrors our own instincts. We, too, extract resources wherever we can. We mine rocks, drill oceans, split atoms, catch photons. If we could harvest the sun itself, would we not try? To project that instinct outward is to imagine that others, too, would see stars not as symbols, but as supplies. Picture the process more closely. As Swan R2 nears perihelion, it unfurls its enormous tail. Plasma streams past, channeled invisibly. Within its coma, exotic matter is concentrated, stored in crystalline matrices, locked away for journeys we cannot imagine. They notice what our own eyes could never see: a point of light that moves when everything else is still, a whisper of brightness where darkness should be. The Atlas survey in Chile is one such set of eyes. In the dry air of the Atacama Desert, 4 robotic telescopes sweep their gaze across the heavens. Each night, they collect gigabytes of data, mapping millions of stars with mechanical precision. Atlas darts nearby, its smaller surface outgassing in bursts that might look like random jets, but could, in this story, be signals, status updates, coordination pings, silent code between harvester and scout. The sun's fierce energy becomes not only illumination, but fuel for an ancient system, still running in the background of the galaxy. Whether literal or metaphor, the imagery has power. It reminds us that we live in an economy of nature. Plants harvest sunlight through leaves. Animals harvest plants. We harvest both. Even comets, in their natural way, harvest energy by turning frozen silence into radiant tales. To call this harvest is not only to speculate about alien engineering, but to recognize a universal pattern. Survival requires collection, transformation, and use. The comets may be nothing more than ice, but they act as harvesters all the same. And so the scenario becomes both wonder and warning. If advanced civilizations harvest stars, what does that make us? Owners, observers, or simply incidental bystanders? Do we have any claim to the sun, or is it part of a common galactic landscape? Would a harvester even notice us? Or would we be like ants, living beside a human power plant, irrelevant to the larger operation? The questions touch on cosmic ethics, on property and territory at scales too vast for human law. Yet as you close your eyes tonight, let the science slip into dream. Imagine Swan R2's tail not only as a spray of dust, but as a net cast wide across space, glowing with captured light. Imagine Atlas, flaring green as it measures flows, adjusting trajectories unseen. Imagine the sun itself as a well of power, its plasma fields briefly tapped, its radiation briefly borrowed, before the comets slip away again. You are not just watching comets, you are watching an energy economy written in fire. And then, let the thought soften. For whether machines or not, these visitors remind us of something profound: that light itself is harvest, that every leaf and every breath on earth depends on gathering the Sunday. We are part of this harvest too, dependent on a star's generosity. Atlas and Swan R2, in their silence, simply mirror that truth on a cosmic scale. So sleep now with the image of comets harvesting fire. Picture nets of light, funnels of plasma, fields of energy stretching across the void. Whether true or imagined, they remind us that the universe is not empty, but full of cycles of giving and taking, burning and gathering, shining and fading. And in that thought, perhaps, is the most comforting harvest of all the sense that we, too, are sustained by the same star, part of the same endless rhythm. In the theater of speculation, not every story ends with harmony. Some whisper of conflict, of rescue, retrieval, or purge. When 2 comets appear together, both extraordinary in their own ways, it is natural to wonder if their duet might also be a drama. Perhaps October 2025 is not only a season of coincidence, but the stage for a quiet cosmic confrontation. The rescue scenario is the gentlest interpretation. In this telling, Atlas is not a healthy traveler, but a failing one. Its strange nickel emissions, its persistent green glow, are not exotic chemistry but distress signals, leaks from damaged systems, cracks in its armor. It has wandered for ages, carrying its mission faithfully, but now, nearing the sun, it falters. Swan R2, vast and luminous, emerges not as rival, but as ally. Its sweeping tail hides the unfurling of rescue equipment. Its coma shelters Atlas from solar radiation. In this dream, the two comets meet in silence, one extending aid, the other accepting. What we see as gas and dust could be life support, data transfer, or stabilization. A rescue hidden in plain sight. The retrieval scenario adds a sharper edge. Here, Atlas is not broken, but complete. It has carried its reconnaissance, gathered its data, and now it is time for recovery. Swan R2 arrives as a collector, a vault designed to retrieve what the smaller scout has gathered. The encounter near the sun becomes a rendezvous. Atlas delivers its cargo information etched into ices, compressed into crystalline codes, and Swan R2 absorbs it, preserving it for the long return. To us, the handoff might look like a collision, or fragmentation, or a sudden dimming. But within that apparent chaos, an exchange might take place, mission accomplished, scout absorbed, records secured. And then there is the purge. This is the darkest script of all. What if you were told that this October, for the first time in human history, two entirely different cosmic travelers would converge on the same stage, each with its own story, its own mystery, and its own destination? Hey guys, tonight we'll drift together into the quiet wonder of these two celestial wanderers. 3I Atlas, an interstellar traveler from the gulf between the stars, and Swan R2, a comet born in the frozen vaults of our own solar system. It is there, in July of 2025, that one of these silent instruments noticed something unusual, a pixel glowing where none should exist, a point of light that shifted position ever so slightly, as though restless in a sea of stillness. It was the first hint of 3I Atlas, the interstellar wanderer on its way toward our Sunday. But Atlas is not alone in its vigil. Across the world, in Arizona, the Catalina Sky Survey watches the skies with equal devotion. In New Mexico, the Linear Project does the same. In it, Atlas is not meant to survive. Perhaps it has revealed too much, its anomalies too noticeable. Its chemistry nickel without iron, green without end, has betrayed a secret. Swan R2 appears not as savior or collector, but as eraser. Its task is to destroy, to sanitize, to ensure no evidence remains of Atlas's true nature. The timing, just as both comets slip into solar glare, is perfect. Earth's telescopes go blind. Whatever happens behind that curtain of fire remains unseen. When they emerge, perhaps one will be missing, or broken, its fragments dispersed in sunlight, a purge carried out in silence. None of these scenarios have evidence. Our instruments detect no signals of coordination, no anomalous accelerations, no artificial light. Both comets behave as comets should, sublimating, outgassing, following gravity's pull. And yet, the mind finds comfort in narrative, even when it involves conflict. For conflict, too, is story. We are creatures of drama, and we project it onto the stars. Imagine watching the October sky with these tales in mind. You see Swan R2 blazing with a tail longer than the full moon's width. You know Atlas is out there too, faint and green, even if harder to find. And in your imagination, you picture them moving toward each other, one wounded, one strong, one whispering, one answering. The heavens become a stage, and you, a solitary viewer, wonder which script is being performed tonight. The rescue play is soothing, for it imagines care in the cosmos that even machines, if machines they are, extend compassion. The retrieval play is practical, a reminder that missions end and assets must return. The purge play is unsettling, yet it satisfies the instinct that secrets are not easily allowed to escape. Together, they form a trinity of possibilities: help, harvest, or erasure. From Mars, perhaps, we might glimpse a clue. Its orbiting spacecraft, turned outward during Atlas's flyby, may record subtle changes: a sudden brightening, an unexplained shadow, a dust cloud forming between them. But even these would be ambiguous. Natural comets fragment often. Outbursts are common. To interpret them as rescue, retrieval, or purge requires imagination. And imagination, in this season, is inexhaustible. Think of how our own species writes its dramas. We rescue stranded vessels. We retrieve satellites at the end of their missions. We also erase destroying malfunctioning probes before they reveal too much. The cosmos may reflect our tendencies, or perhaps we simply reflect them outward, painting our patterns onto the void. As you drift into sleep, let the conflict play out gently in your mind. Picture Swan R2, unfurling its luminous veil, not only for beauty, but for purpose. Picture Atlas, green and fragile, gliding into its shadow. Perhaps they exchange signals invisible to us. Perhaps they embrace in dust and plasma. Perhaps one disappears. Whatever the outcome, the stage remains silent. No sound carries across the vacuum. No cries, no explosions, only light, only the whisper of radiation. The universe fights, too, in silence. When dawn comes and the comets vanish into solar glare, we will not know what truly happened. We will only see what emerges later: two comets, or one, or none. The truth may remain hidden forever, lost behind the curtain of the Sunday. But the story will live on, in the minds of those who stayed awake to wonder. For sometimes, conflict is not about victory or defeat. It is about transformation. If Atlas vanishes, perhaps it is not destroyed, but reborn, its fragments scattered to seed new worlds. If Swan R2 absorbs it, perhaps it becomes more than comet, more than fortress, more than we can imagine. Even the purge, harsh as it sounds, may serve a larger purpose, removing what is not meant to remain, preserving balance in ways we cannot yet understand. So rest now, with this possibility in your thoughts, that the cosmos writes not only tales of harmony, but also of tension, rescue, and silence. That even in the grand ballet of stars, there may be moments of confrontation hidden from our eyes. And that you, tonight, are part of the audience, lying beneath the stage lights of October, listening to a play performed in silence and light. There comes a moment in every skywatcher's year when the instruments go blind. Telescopes that for months have faithfully tracked faint lights across the heavens suddenly lose their grip, overwhelmed by the brilliance of the Sunday. For Atlas and Swan R2, that moment arrives in October 2025. Above Earth's atmosphere, the Neowise satellite circles silently, searching for asteroids, comets, and anything else that does not belong. Together, these systems form a chorus, a global network of instruments whispering to one another through data streams. Each night, they compare notes, aligning their observations, refining their calculations. It is not only professionals who listen. Amateur astronomers, too, join this quiet symphony. Their paths carry them deep into solar glare, where no earthly eye can follow. This is what astronomers call the October silence. Imagine observatories around the world, screens glowing in dim control rooms, data streams scrolling endlessly. Night after night, scientists compare spectra, measure brightness curves, refine orbital plots. Then, one evening, the signals begin to fade. The comet's glow sinks into dawn, vanishes behind the curtain of day. Instruments saturate, coronagraphs bloom with light, and finally the stream stops. Where once there was data, there is only noise. The watchers sit back in their chairs, and silence fills the room. It is not true silence, of course. Machines still hum, computers still calculate. But the silence is of absence, the absence of photons, the absence of certainty. For weeks, perhaps months, humanity loses sight of both comets at the very moment their stories reach their peak. The sun has stolen them from view, and with them, the answers to our questions. Did Atlas fragment under heat? Did Swan R2 erupt in a final display? Did anything unusual happen as they swung close to the solar furnace? We cannot know. This silence is both frustrating and fertile. Into the gap rush. Speculation, art, myth. On social media, theories multiply. Some imagine the comets rendezvousing unseen, exchanging secrets. Others predict catastrophe, collisions, revelations. Without data to anchor imagination, every possibility grows roots. Artists paint luminous encounters. Poets write verses about hidden dialogues. The silence becomes a canvas for human yearning. Astronomers, by contrast, wait patiently. They know this cycle well. Comets often slip behind the sun, lost in glare, only to emerge weeks later, changed but still present. Their discipline is to hold the line, to let models predict what the eyes cannot see. Orbital mechanics continues in silence. Equations do not falter just because telescopes do. And yet, even the scientists feel the tension. For predictions can be wrong. Fragile comets sometimes do not survive. Silence can end not with a reappearance, but with absence. Picture yourself outside on a cool October evening. You know that Atlas and Swan R2 are there, just beyond sight, hidden in daylight's blaze. You cannot see them, but you feel their presence, like actors waiting in the wings. The night sky is quieter without them, emptier. The silence is not only in observatories, it is in you too, in your waiting heart. The October silence also carries echoes of older traditions. Ancient cultures often marked the disappearance of comets with ritual. When a star vanished, they filled the gap with meaning, omens, prophecies, songs. We do the same now, though our rituals wear modern clothes, articles, podcasts, speculative videos. The impulse is unchanged. When the heavens fall quiet, we tell stories. And perhaps this is the true gift of the silence. It invites us to reflect on what we seek in the sky. Are we hunting for data or for meaning? Are we measuring molecules or searching for metaphors? The absence of observation forces us inward to our imaginations. We create narratives, not because the comets demand them, but because we do. Nauris. Silence reveals our own hunger for connection. For those who sleep beneath this silence, the dreams can be vivid. You might dream of Atlas glowing green behind the sun, its surface splitting, releasing streams of hidden code. You might dream of Swan R2 unfurling vast collectors, harvesting solar fire unseen. Or you might dream simply of emptiness, a dark sky without answers, waiting. Each dream is a response to the silence, a way of filling the void. When December arrives, the comets may return to view. Perhaps Atlas will emerge dimmer, scarred by its solar passage. Perhaps Swan R2 will glow fainter, its tail shortened by time. Or perhaps one will be missing, leaving astronomers to puzzle over fragments or dust. The silence will break, but it may not bring clarity. It may bring new mysteries, new debates, new silences to follow. In the meantime, we are left with waiting. Waiting is its own kind of science, its own kind of art. It teaches patience, humility, trust in the unseen. In the October silence, the comets continue their paths, whether we watch or not. They are not dependent on our gaze. They remind us that the universe does not revolve around human observation. It unfolds regardless, immense and indifferent, and our task is to notice when we can. So let yourself rest with that thought. The silence is not emptiness. It is part of the rhythm. Appearance, disappearance, reappearance, like breath, like sleep. One of them, Vladimir Bezugli, sat before his computer in September 2025, reviewing images from the Swan instrument aboard the Solar and Heliospheric Observatory. His eyes, sharpened by habit, caught what others missed, a faint brightening, a ghost of a tail. That ghost would soon be confirmed as Swan R2, the comet destined to sweep across our skies like a luminous veil. What is hidden now will one day return, though perhaps not as it was. The comets vanish into fire, but the story does not end. It only pauses. Close your eyes and imagine the October silence. Imagine two travelers slipping behind the sun, unseen but not gone. Imagine the whole world waiting, instruments idle, hearts curious. The silence is not threatening. It is gentle, like the pause between movements in a symphony. In that pause, you can hear yourself breathe. You can feel the vastness around you, and you can drift into sleep, knowing that even when the sky grows quiet, the story continues beyond your sight. Silence never lasts forever. After weeks of absence, after the long eclipse behind the sun's glare, the comets return. Astronomers wait for this moment with a patience born of centuries, their models calculating where and when the travelers should emerge. They know the odds most comets survive. Some fragment, a few vanish entirely. What October hides, December reveals. This is the moment when the data comes back. Imagine the scene at an observatory. It is just past dusk, the dome creaks open, and the telescope turns toward coordinates predicted weeks before. Screens glow faintly in the control room, and scientists lean forward in anticipation. Then, there it island. A faint smear of light against the black, a point that moves just slightly differently from the stars. Atlas has returned. Its glow is dimmer, its coma thinner, but unmistakably it endures. Across the world, other observatories confirm the sighting, each detection like a heartbeat restarting after a pause. And Swan R2, it, too, comes back into view. Its once grand tail may now be shortened, reduced to a veil of dust. Its brightness has waned, but the shape remains. Like a fire after embers cool, it still radiates warmth, though less fiercely than before. Astronomers record magnitudes, update orbital charts, feed new data into software. The silence has ended, and with it, the season of speculation begins to resolve into measurement. But what did the silence change? The first spectra after reappearance hold answers. Lines shift, intensities alter. Molecules that once dominated may have vanished, replaced by others. Nickel lines may fade. Cyanogen signatures may weaken. Water vapor may rise as deeper layers of ice sublimate. Each alteration is a clue. Each variation, a whisper about what happened unseen. Was there a violent outburst? Did the nucleus fracture and reassemble? Or did the comet simply endure, scarred but steady? There is poetry in this process. The silence is like a missing chapter, and the returning data is its aftermath. We do not see the climax, we see the consequences. It is like waking from a dream where the middle is forgotten. Only the beginning and the end remain. Yet in those bookends lies enough to guess the story. Scientists pore over graphs, matching them against predictions, asking, did nature follow the script or improvise something new? Consider Atlas, If it emerges unchanged, then its mystery remains chemical, not structural. If it emerges fragmented, its green glow dispersed into smaller shards, then its story shifts an interstellar visitor, undone by our Sunday, the brightness curve will tell. If it falls below expected magnitudes, it may mean the nucleus cracked, its surface area diminished. If it exceeds predictions, it may mean new surfaces have been exposed, releasing fresh volatiles in a final display. The data does not only describe it, narrates. Swan R2, too, writes its own postscript. If its tail shortens, we know it has spent much of its fuel. If dust trails linger in orbit, we may see meteor showers months later, Earth passing through particles left behind. Each streak of light across our skies could then be a message from October. Fragments of Swan R2 burning briefly above us, reminders that even silence leaves traces. The return of data is not only a scientific act, it is an emotional one. For months, astronomers live with uncertainty. They speculate, they debate, they wonder. Then suddenly the universe speaks again, and relief floods in. The comets survived, or they didn't, but either way, the not knowing is over. The silence is replaced by sound, the steady sound of photons arriving, of instruments recording, of meaning being rebuilt. And for the rest of us, who may not read data directly, the return is felt in news reports, in images shared online, in whispers of wonder that travel across conversations. In that moment, the professional and the amateur, the machine and the human, joined hands across continents, united by curiosity. Each instrument speaks in its own dialect. The CCD camera talks in pixels. The spectrograph sings in wavelengths of light, breaking starlight into a rainbow of information. Radio dishes hum with the faint hiss of signals carried across millions of kilometers. None of these voices sound like ours, yet together they weave a tapestry of meaning. The comets are back, people say. We can see them again. Even faint, even altered, their reappearance reassures. They were not lost to fire completely. They still belong to the story of the sky. Perhaps, though, something unexpected will appear. A color not seen before. A trajectory subtly altered. A tail kinked or severed. Even the smallest anomaly is magnified by the silence, for it happened while we were blind. And so scientists proceed carefully, cataloguing each change, comparing each detail to models. In the small differences lie the big questions: natural outburst or hidden design, coincidence or coordination. The data will not shout an answer, but whisper, and those whispers must be interpreted with care. In the quiet of your own thoughts, imagine yourself as one of those photons. You left the comet weeks ago, streaming outward through space. You dodged the sun's glare, crossed the void, entered a telescope's mirror, and finally fell upon a sensor. You carried with you the story of what happened behind the curtain, encoded in color and intensity. You are a messenger, a speck of truth. Multiply yourself by billions, and you are the returning data. There is something deeply human in this act of waiting and receiving. We cannot follow the comets into the sun's glare. We cannot watch their most dramatic transformations. But we can wait. We can prepare. We can listen for their return. And when they reappear, faint but present, we welcome them like travelers emerging from fog, carrying news of lands we could not see. So rest now with that thought. The silence will always end. What vanishes behind brilliance will one day return. The comets will emerge, altered or unchanged, and their data will flow back into our hands. We will read their stories not as eyewitnesses, but as interpreters, piecing together fragments. And in that act, patient, humble, hopeful, we reveal not only the nature of comets, but the nature of ourselves. Long before telescopes, long before equations and spectra, comets were storytellers. They appeared suddenly, with no warning, streaking across the night sky, like omens written in fire. For ancient civilizations, such arrivals were not curiosities, they were signs. Kings trembled, priests whispered, farmers paused in their fields to stare. A new light in the heavens always meant change. And though we now measure comets with instruments and theories, part of us still feels those echoes when one blazes into view. Atlas and Swan R2, arriving together in October 2025, naturally awaken these older instincts. Two lights, different yet simultaneous, seem almost mythic. We think of patterns, archetypes, stories humanity has told for millennia. To see them together is to feel not only science at work, but myth resurfacing. For comets have always carried dual meanings, harbingers of doom, heralds of renewal, symbols of both fear and hope. The Babylonians recorded them as messages from the gods, omens of plague or conquest. The Chinese catalogued their shapes in bamboo scrolls, each curve of a tale interpreted as a prophecy for empire and harvest. In medieval Europe, comets were dreaded as swords in the sky, predicting wars or the fall of rulers. When Halley's comet appeared in 1066, the Bayeux tapestry depicted it as a fiery sign above the head of King Harold, foretelling his defeat at Hastings. And yet, not all interpretations were dark. For the Maya, celestial visitors were part of cycles, marking the rhythm of creation and destruction, life and rebirth. In Polynesian traditions, comets were navigational signs, guiding seafarers across vast oceans. Even within European lore, some saw them as torches, lighting the way toward new ages. The ambiguity was always their comets could destroy, or they could illuminate. Now imagine two arriving at once. Ancient eyes might have seen them as twin omens, one bright and sprawling, one green and sharp. Perhaps they would have been cast as siblings, rival gods, or a messenger and a guardian. Their convergence could have been read as a prophecy of great upheaval, or as a blessing of balance. In myth, dualities often matter light and dark, order and chaos, life and death. Atlas and Swan R2 seem to echo that timeless pairing. Science explains their chemistry, their origins, their orbits. But when we step outside under October skies, the old feelings return. To see Swan R2's veil stretch across stars is to understand why ancestors spoke of omens. They tell us how bright a comet becomes, how its orbit curves, what molecules shimmer in its coma, and slowly, as the nights pass, they transform data into knowledge and knowledge into story. Imagine standing beside one of those telescopes on a clear night. The air is still, the mountain cold, the dome above you creaks softly as it turns. You would not hear the stars, you would not hear the comet, yet you would feel the presence of something ancient, something vast. To glimpse Atlas's faint green lantern is to feel the mystery they could never name. We are, in truth, no different. We seek meaning in what we see. Instruments may tell us composition, but our hearts tell us story. This is why myths endure. They are not falsities, but interpretations, ways of connecting human life with the larger cosmos. When a comet appeared during famine, it was linked to hunger. When it rose before war, it became a sword of prophecy. Patterns emerge not because the heavens change to suit us, but because we look upward in search of mirrors. Atlas and Swan R2, whether natural or extraordinary, are part of that mirror now. Perhaps in some deep way, our modern interpretations are not so distant from the ancient ones. When scientists debate whether Atlas might be artificial, or whether Swan R2 hides a larger purpose, are we not echoing the same impulse to see intention in light, to imagine design in coincidence? We use the language of technology instead of gods, but the longing is the same to believe the universe is speaking to us. Imagine yourself as one of those ancestors. You stand in a field, no telescope in hand, only your eyes. The night is cold, the stars are sharp. And there, above the horizon, a luminous streak spreads across the heavens. Another, smaller, green flame lingers nearby. You do not know chemistry or orbital mechanics. You only know that the sky has changed, and with it, perhaps, the world. You whisper to those beside you that the gods are restless, that change is near, and in your bones you believe it. Now return to the present. You know their names: Atlas, Swan R2. You know their distances, their compositions, their orbits. And yet, as you watch them, you feel the same awe, the same tremor of significance. The ancient patterns still live in you. The comets are not only icy wanderers, they are symbols of transition, reminders that time itself is a cycle. When they pass, the world feels different, even if nothing has changed. As you drift towards sleep, let yourself embrace those patterns. Imagine Atlas and Swan R2 not as data points, but as storytellers. One writes in green light, the other in sweeping dust. Together, they inscribe a chapter into humanity's long history of sky-watching. Whether you call them omens, symbols, or just comets, they carry the same gift, the ability to remind us that we are part of something vast, ancient, and mysterious. And perhaps that is the true meaning of comets, not their chemistry, not their trajectories, but their power to awaken imagination. From Babylon to Beijing, from Viking sailors to modern astronomers, comets have been mirrors of our hopes and fears. Atlas and Swan R2, arriving together in this October, simply continue the story, inviting us to find patterns in their light. So rest now, with ancient echoes in your thoughts. Picture a tapestry where comets blaze above kings. Picture scrolls where their shapes foretell fortune. Picture fireside stories where they bring both dread and wonder. Then look at the modern sky, where two comets shine together, and feel the continuity. The universe has always spoken in patterns. We are simply learning to listen again. There is one hypothesis more haunting than alien couriers, more mysterious than cosmic harvesters. It is the idea that the comets are not messages from others, but messages from ourselves, from a future humanity reaching back across time. If Atlas and Swan R2 seem too coincidental, too perfectly timed, perhaps it is because they were never meant for anyone else. Perhaps they are shadows of our own future, cast backward into our present. The concept is daring. Time, as we know it, flows forward. Causes precede effects. Signals move outward. Entropy increases. Yet physics leaves small cracks in the wall. Relativity suggests that time is not absolute, that under extreme conditions it can bend. Quantum mechanics leaves hints of retrocausality, where outcomes influence beginnings. In this faint margin of possibility, dreamers place the idea that humanity, one day, will learn to send objects not only across space, but across time. If so, what form would such messages take? They could not be fragile electronics or short-lived signals. They would need to endure millions of years, withstand cosmic radiation, and slip unnoticed into natural rhythms. Comets, then, become the perfect disguise. Durable, ordinary-looking, capable of carrying information in ice layers or isotope ratios. The telescope would open its shutters, and photons older than human history would fall upon its sensors. Each photon, a messenger, each one, a story from far away. And as those photons accumulate, patterns begin to emerge. The green glow of 3I Atlas is traced back to molecules that fluoresce in the presence of sunlight. The rapid brightening of Swan R2 hints at volatile ices breaking free, releasing gas into the vacuum. A future humanity might hollow one, inscribe data into crystalline lattices, and launch it on a trajectory carefully tuned to intersect with Earth at the right moment. Another, larger comet, might be engineered or nudged to arrive nearby, ensuring redundancy. Atlas and Swan R2 could be less coincidence, more choreography, our descendants, leaving us a note written in stars. The message might not be words, it could be chemistry. Nickel without iron, cyanogen in abundance, green glows too steady to ignore. Each anomaly becomes a symbol, a glyph. We read them as oddities, perhaps they are codes. The two comets arriving together might be punctuation, not one mark, but two, bracketing a sentence in cosmic language. If so, what do they say? Warning, encouragement, a reminder of survival. It is unsettling to think that our future selves might intervene. Why would they? Desperation, perhaps. A world facing collapse might send warnings backward, hoping ancestors could alter fate. Or perhaps not desperation, but guidance. A civilization so advanced it bends time might send gifts, archives of knowledge, or seeds for continuity. The comets could carry blueprints for survival, written not on paper or screens, but in molecules and spectra. To us, they are anomalies. To them, they are carefully designed symbols. Skeptics argue that this is only story. No evidence suggests backward causation on this scale. And yet, the appeal remains because it touches something deeply human, the longing to know that we endure, that we have a future worth reaching back from. To imagine comets as shadows of our own descendants is to imagine that we are not only observers of the cosmos, but participants in a longer arc of time, one that loops upon itself like a river turning back. Picture lying beneath the October sky. You see Atlas glowing green, faint but steady. You see Swan R2, sprawling and magnificent. In that moment, imagine they are not strangers, but kin. Imagine that deep within their ice is the touch of human hands, not our hands, but future ones. They have sent themselves across centuries to greet you, to tell you that humanity's story does not end here. The thought is tender, almost comforting, as though someone far ahead is watching over you. In dreams, you might take it further. You might imagine what the message could be. A cure encoded in chemical ratios, a star map etched in dust trails, a warning embedded in orbital timing, or perhaps no message at all, only presence. Sometimes, to know that someone still exists is message enough. The comets, then, are not carriers of instructions, but silent reassurances. We were here. You will be too. Even if the hypothesis is only metaphor, it holds power. For in a sense, we already do send messages to the future. Our broadcasts ripple outward. Our probes drift into interstellar space. Our writings and art may endure for centuries. Each of us leaves shadows of ourselves, hoping someone will one day receive them. The comets simply magnify that instinct to a cosmic scale. They remind us that time is not only what we pass through, but what we shape with memory and meaning. As you close your eyes tonight, let yourself rest in that possibility. Imagine Atlas and Swan R2 not as random wanderers, but as emissaries from a future where humanity has survived, advanced, and reached back. Imagine their paths as lines drawn deliberately, their chemistry as whispers from tomorrow. Even if untrue, the idea awakens something hopeful that our story does not end in silence, but continues in ways we cannot yet conceive. So let the shadows of the future comfort you. The comets glide across the sky, and with them drifts the thought that humanity may one day master not only the stars, but time itself. And tonight, you are part of that dream, lying beneath their light, wondering if what you see is not just the past of the cosmos, but the future of yourself. There are moments when the universe speaks not in data, but in silence. And in that silence, dreams take root. For many weeks in October, Atlas and Swan R2 slip behind the sun, invisible to human eyes. Telescopes fall quiet, models run without fresh updates, and all we can do is wait. But waiting itself is fertile. In the absence of observation, imagination flowers. Astronomers dream of spectral lines shifted, new molecules revealed, puzzles deepened. Poets dream of lanterns and veils, of two strangers passing messages in fire. Children, looking at glowing illustrations in news articles, dream of dragons in the sky, tails stretching across the stars. Silence does not stop us. Nickel without iron, tails that stretch across degrees of sky, trajectories that defy simple probability. All these whispers become threads in a puzzle. The instruments gather them without judgment, without speculation. They simply watch. But the watching itself is fragile. Instruments can deceive as well as reveal. Algorithms trained to recognize predictable motions sometimes miss what is truly strange. It encourages us. Where the data ends, the dream begins. Atlas, with its emerald glow, becomes a symbol in these dreams. Some imagine it as a lantern carried by a traveler, lighting the way through the dark. Others see it as an eye, watching, unblinking, waiting for us to notice. Its persistent green whispers of growth, of renewal, of life hidden in cold stone. Swan R2, by contrast, becomes a canvas vast, luminous, painted across the horizon. It is a brushstroke too large to ignore, a reminder that beauty can appear suddenly, dramatically, and vanish just as quickly. Together, they create a dialogue in the human mind. One small and swift, one large and sprawling, one sharp, one soft. The duet invites metaphor, scout and fortress, messenger and reply, spark and flame. We cannot help but weave meaning, because we are pattern-seeking creatures. To dream is to interpret, even when there is nothing yet to interpret. The October silence becomes a collective dreamscape. Around the world, people imagine what is happening behind the curtain of sunlight. Are the comets exchanging secrets? Are they fragmenting, colliding, or simply enduring? Every possibility spins into story. Internet forums share theories, from scientific to fantastical. Artists create glowing paintings of cosmic dances. Writers sketch short tales of green messengers and white giants meeting in solar fire. For a time, the comets live not in the sky, but in our shared imagination. There is something tender in this. We are reminded that science and art are not rivals, but companions. Data gives us truth, dreams give us meaning. Both are needed, and both thrive in silence. The comets, in their absence, become muses, sparking creativity across disciplines and cultures. Just as ancient people embroidered myths onto the sudden arrival of comets, we embroider speculation onto their sudden absence. The pattern is old, but endlessly renewed. Imagine yourself beneath a quiet night sky in late October. The stars are steady. The planets march along their paths. But the comets are gone. Hidden by the Sunday, you know they are there, but you cannot see them. In that gap, your mind begins to wander. You picture Atlas glowing green, not as a comet, but as a torch carried by some unseen traveler. You picture Swan R2 spreading its luminous cloak, shielding or revealing. You picture them meeting behind the solar curtain, exchanging what they carry. You are dreaming, but your dream feels as valid as any measurement. And this is the gift of such silences. They remind us that knowledge is not only about answers, but about questions. To sit in uncertainty is to allow imagination to breathe. Our ancestors called this myth. We call it speculation. But the root is the same, a refusal to let the sky remain mute. When December arrives and the comets emerge again, the dreams will fade, replaced by data. Numbers will confirm or deny. Spectra will sharpen. Orbits will be refined. But something of the dream will linger. Even with answers, The memory of the silence, those weeks when anything was possible, will remain. In some ways, that memory is more powerful than the answers themselves, for it teaches us that science is not only about certainty, but also about wonder. The dreams of October also mirror our own lives. How often do we pass through silences, moments when nothing seems to move, when answers are hidden, when the future is unknown? In those moments, too, we dream. We imagine outcomes. We create stories. We fill the gap with hope or fear. The comets remind us that this, too, is natural. Silence is not emptiness. It is the soil where dreams grow. So as you rest tonight, let yourself dream alongside the comets. Picture Atlas and Swan R2 hidden behind the sun, their fates unknown. Picture the universe holding its breath, waiting. And in that waiting, let your imagination bloom. Perhaps they are machines, exchanging data. Perhaps they are harvesters, drawing fuel. Perhaps they are simply comets, beautiful and transient. Whatever the truth, your dream is part of the story. In the end, dreams are not about accuracy, they are about possibility. They prepare us for wonder, they soften us for revelation. The October silence, filled with dreams, ensures that when the comets return, we will be ready to see them anew. Close your eyes now and let the silence carry you. Atlas glows green in your mind. Swan R2 spreads luminous across the sky. You drift into sleep, holding them both, knowing that even when the universe grows quiet, your imagination can still speak. And in that gentle voice, the cosmos becomes not distant, but intimate, a dream shared between you and the stars. Automated filters smooth out irregularities that might have been the very clue we were seeking. A comet's brightness curve can rise and fall in ways that mimic noise, even when something real is happening beneath the surface. And so, human eyes must return to the data, sifting through the whispers, deciding what is genuine and what is illusion. Consider how delicate this process. Island A. Single miscalculated point can shift the entire orbit of a comet on paper. Every story must end, though endings are rarely final. The comets Atlas and Swan R2 will fade, their brightness diminishing as they drift outward into colder realms. Observers will archive their spectra, orbital data, and brightness curves. Papers will be published, conferences held, debates continued. Yet even when all the numbers are written down, one question will linger in the air, quiet but persistent. What were they, truly? The scientific answer is straightforward. They are comets, icy remnants of stellar formation, shaped by gravity and chemistry. Atlas is an interstellar visitor, the third ever discovered, its hyperbolic path proof of an origin beyond our sunday. Swan R2 is a long-period comet from the Oort cloud, disturbed by galactic tides and drawn inward after millennia of sleep. Together, their simultaneous arrival is improbable, but not impossible. Nature allows coincidences, and sometimes they happen in our lifetime, and yet the imagination resists closure. Too many anomalies invite speculation. Atlas, glowing emerald with nickel but no iron, its chemistry strange. Swan R2, blazing across the sky in the same season, too conveniently timed. Their convergence in October, their disappearance together into the sun's glare, their reappearance altered. It feels like choreography, even if it is chance. And so the question remains, not only in laboratories, but in hearts. Were they scouts and fortresses, machines cloaked in ice, executing missions we cannot decipher? Were they relays, exchanging signals behind the solar curtain, using our star as amplifier? Were they harvesters, dipping into plasma fields for exotic matter, nets unfurled in luminous tails? Or were they simply comets, beautiful, natural, coincidental, whose only purpose was to remind us of how easily awe awakens when we look upward? The beauty of the question is, that it does not demand an answer. It asks us only to dwell in wonder. To sit with uncertainty is not weakness, but strength. The history of science is filled with mysteries that endured for centuries before clarity came. Some will say we must resist myth, cling only to data. Others will say myth is how humans survive the silence. Both are true. Atlas and Swan R2 are not only physical bodies, but mirrors for our imagination. They reveal not only the cosmos, but ourselves. Picture, if you will, the sky in December, when both comets are faint but present once more. Atlas glows softly, its green halo diminished. Swan R2 stretches a shorter, dustier tail. Their brilliance has passed, but they still drift silently, witnesses to their own story. You look up and realize you are one of the few generations in all of history to see such a duet. Long after they leave, you will remember this season, when two comets crossed paths and left you with questions that linger like dreams. The question is not only about them, but about us. Why do we yearn for meaning? Why do we see scouts, fortresses, replies, when data shows only ice? Perhaps because we, too, are wanderers. We, too, seek purpose in our journeys. A comet without meaning feels too empty. And so we give them stories, not because they demand them, but because we do. In that way, the comets fulfill a mission, whether natural or not. They remind us that science and myth are not opposites, but companions. Science measures their spectra. Myth measures our response. Both truths are needed. Together, they make the question eternal. As you close your eyes tonight, let that question drift with you into sleep. Were they comets, fortresses, or replies? You do not need to decide. You need only to remember that you saw them, that you wondered, that you let the silence and the light shape your imagination. That is enough. For in the end, the universe does not always give us answers. Sometimes it gives us mysteries, wrapped in green light and sweeping tales, timed so perfectly we cannot help but feel they were meant for us. Whether coincidence or choreography, Atlas and Swan R2 have already achieved their purpose. They made us look up, they made us dream, they made us ask. And that question will remain, echoing long after the comets fade, scouts, fortresses, or replies, or something else beyond words. The answer may never come, but the asking is its own reward. So rest now, with the comets in your thoughts. Let their tails sweep across your dreams. Let their silence deepen your wonder. Let their mystery comfort you. For you are part of the same sky, the same story, the same question. A single misread spectral line can invent or erase a chemical signature. This is why astronomy is as much art as science. It requires patience, humility, and an openness to mystery. For each measurement that seems certain, another remains uncertain, and in those uncertainties, imagination blossoms. When the Very Large Telescope in Chile turned its gaze on 3I Atlas, it caught something unexpected: nickel emissions without the usual companion of iron. And perhaps that is the true gift of Atlas and Swan R2, not their arrival, not their departure, but the reminder that even in uncertainty, beauty endures. It was like reading a sentence missing its final word. The pattern was incomplete, and that incompleteness demanded explanation. Later, when the James Webb Space Telescope studied the same visitor, it found a composition rich in carbon dioxide, but curiously poor in water. Another missing word, another gap in the grammar of nature. We'll explore their journeys, their chemistry, their timing, and the strange coincidence, or perhaps not a coincidence at all, that brought them both to our sun within just weeks of each other. So, before you get comfortable, take a moment to like the video and subscribe, but only if you genuinely enjoy what I do here. And if you feel like sharing, let me know in the comments where you are listening from tonight and what time it is where you are. Now, if you're ready, let's begin. The Swan instrument, designed not to hunt comets at all but to map hydrogen atoms from solar interactions, nonetheless revealed Swan R2 with a sudden burst of activity. Once again, the instruments whispered what they were not meant to whisper. You might think of them as oracles, mechanical seers peering into the dark, telling us stories we are not yet wise enough to fully interpret. They do not lie, but they do not tell the whole truth either. They give us fragments, and we assemble those fragments into meaning. Sometimes we succeed. Sometimes we build castles in the air. Yet always, the sky rewards the effort. Stand again beneath the October night, and imagine the world's instruments turning toward the heavens together. Telescopes in Chile, Hawaii, and the Canary Islands hand off the comets from one to another as Earth rotates. Satellites above the atmosphere provide continuity, immune to weather and clouds. Amateur astronomers in backyards add their own pixels and sketches. It is a collaboration larger than any single person, a global act of collective wonder. And yet, for all the machinery and calculation, the universe keeps its secrets well. Instruments whisper, but they never shout. They give us glimpses, but not conclusions. As October deepens, 3I Atlas and Swan R2 sink toward the sun, into regions where glare blinds even the best detectors. The instruments will continue to listen as long as they can, but soon silence will descend. We will wait, holding our breath, wondering what they will be when they emerge again. Perhaps that is the lesson of the instruments: patience. To watch without expectation. To gather without judgment. To trust that even silence has meaning. In the quiet accumulation of photons, in the steady hum of machines, in the whispered language of data, we learn not only about comets, but about ourselves, about our hunger to know, our need to listen, and our willingness to wonder. The universe speaks in many tongues, and one of its most subtle languages is the glow of metals. Every atom, when touched by sunlight or stirred by collision, sings in its own frequency. To our instruments, those songs appear as delicate lines in a spectrum: green, red, blue, invisible ultraviolet. Together, they form a vocabulary as precise as any alphabet, and yet as mysterious as poetry. When astronomers turned their spectrographs toward 3I Atlas, they expected the familiar grammar of comet chemistry. But what they heard was a dialect unlike any they had studied before. It was nickel vapor shining in the near vacuum around the comet's nucleus, glowing softly in the green portion of the spectrum. That, in itself, was not shocking. Nickel exists in many comets, meteorites, and asteroids, usually in small amounts, born from the stellar furnaces where heavy elements are forged. What made scientists pause was the absence of iron. In nature, nickel rarely travels alone. It is a companion metal, paired with iron in ratios that echo the deep alchemy of stars. Where you find one, you almost always find the other. But here, in this interstellar wanderer, nickel sang without iron's harmony. It was like hearing a familiar melody, missing its deepest notes. The discovery rippled through observatories. Some astronomers leaned back in their chairs, furrowing their brows, whispering to themselves. Others recalculated, ran simulations, checked for errors in their instruments. Could the readings be wrong? Could iron be hiding in faint signatures beyond detection? But the data was clear. The nickel was strong, the iron nearly absent. A sentence written in light, missing half its expected words. What could explain this theories blossomed like constellations? Perhaps, some said, the comet carried nickel-bearing organic compounds that break down under sunlight, releasing nickel atoms first, while iron remained bound in different structures. Others imagined space weathering, millions of years adrift in the harsh interstellar medium, bombarded by cosmic rays, could have altered its surface chemistry in ways we barely understand. Another idea suggested that the comet's formation conditions, far from here in a cold and alien star system, had been so different from our own that its chemical recipe never followed the rules we take for granted. Picture the sky as it appears on a cool October evening. The air is crisp, perhaps tinged with the scent of fallen leaves. Far from the city lights, where darkness feels deep and undisturbed, the heavens open above you like a velvet dome. It is there, on such a night, that you might glimpse the first of these travelers, 3 Atlas, appearing as a faint green smudge through a modest telescope. Its color is subtle, like a whisper, but undeniable. And then, of course, there were those who wondered aloud if the absence of iron was not natural at all, but intentional. If you were to design a machine to mimic a comet, might you not use metals selectively? Could nickel serve some engineered function, shielding, signaling, or propulsion, while iron was left behind? Most scientists do not dwell on such ideas, preferring explanations grounded in physics and chemistry. Yet speculation, once released, is as difficult to contain as a comet's tail streaming across the sky. Nickel has its own kind of allure. In laboratories on Earth, nickel compounds shimmer with strange colors. In history, humans have used it in coins, armor, and magnets. To see it glowing freely in the cold emptiness of space feels like a reminder that the same elements that shape our lives also dance beyond imagination. Every atom of nickel in 3 Atlas was forged billions of years ago, perhaps in the death throes of a supernova, scattered into space, caught in ice, carried across the dark between stars. Now, warmed by our sun, it reveals itself at last, like a long-kept secret finally whispered. Imagine standing at the eyepiece of a great telescope, though most of these measurements are invisible to human sight. Picture a thin green line appearing across a spectrum chart, delicate but undeniable. That line is not just light, it is history. It is proof of a journey, of conditions no human has ever seen, written in the silent alphabet of the cosmos. When astronomers trace such lines, they are not simply analyzing, they are listening. Listening to metals that hum across vacuum, to molecules that speak without voices, to a language that has no sound, only color. The James Webb Space Telescope added to this strange vocabulary. Its infrared gaze revealed a composition dominated by carbon dioxide, with far less water than expected. Comets in our solar system usually tell the opposite story: water first, then carbon dioxide and carbon monoxide. But 3 Atlas inverted the grammar. It was like a traveler speaking backwards, still understandable, but unsettling. Cyanogen appeared too, a molecule once feared as poison on Earth, now glowing as beauty in the comet's coma. Together with nickel, these features painted a portrait of chemistry, both familiar and alien. If atoms are letters, then molecules are words. Comets write sentences in their tails. Most comets we know write in the same dialect, shaped by the conditions of our solar system. But 3 Atlas composes in a foreign script. Heavy on carbon dioxide, touched with nickel, glowing green with cyanogen, it speaks in a dialect of ice and metal, perhaps learned around a star we will never see. To read it is to strain against the limits of translation, knowing that we catch only fragments of its meaning. Astronomy has seen this before. The second interstellar visitor, 2I Borisov, also carried chemical oddities. Its ratios of carbon monoxide to water were unlike any solar system comet, suggesting origins in a colder nursery. 3 Atlas continues that tradition of strangeness, but with even sharper twists. It seems to remind us not all comets are local, and not all follow rules. And so astronomers debate, write papers, argue across conferences. They fill whiteboards with equations, run models on supercomputers, compare notes with colleagues halfway around the world. They try to reconcile the song of nickel without iron, the abundance of carbon dioxide, the shimmering green glow. The process is both methodical and dreamlike. Scientists standing at the border of knowledge, listening to whispers from the dark. You, too, can imagine yourself there. The dome of a telescope is open to the night. The hum of equipment fills the air, a low mechanical lullaby. Outside, stars drift in their eternal arcs. Inside, a small team stares at graphs on glowing monitors. A thin green line stretches across the screen, and for a moment, silence falls. Everyone knows they are reading something rare, something never before encountered in human history. And though they cannot yet translate it, they feel the weight of its meaning. Perhaps that is what makes 3I Atlas so mesmerizing. It is not simply a comet, nor simply an interstellar object. It is a message written in a language of metals, a language older than Earth, perhaps older than our Sunday. Whether natural or intentional, accidental or designed, it carries a story that unfolds not in words, but in wavelengths. Across the western horizon, after sunset, the second visitor dominates with flamboyance. Swan R2 unfurls a tail that sweeps upward like a cosmic brushstroke, a river of light against the deepening sky. These two are strangers. They were born in different places, under different cosmic conditions. One comes from the interstellar depths, carrying the signature of chemistry that breaks our familiar rules. And as you drift towards sleep, you might imagine those green photons passing through the vastness of space, finally arriving in the lens of a telescope, then in the eyes of a scientist, then here, into your own imagination. The language of metals is quiet, but it endures. Nickel without iron, carbon dioxide without water. Cyanogen glowing, where none expected it, is grammar that challenges our expectations. It is the cosmos reminding us that its sentences are longer than our lifetimes, and its dialects broader than our dictionaries. To listen is to admit that mystery will always remain, and perhaps that is the most comforting lesson of all. Think of the solar system as a vast clockwork, each planet tracing its orbit like a gear turning with quiet precision. The Earth makes its steady circle around the Sun once a year. Mars moves more slowly, Jupiter even slower, each following the invisible instructions of gravity. Asteroids and comets join in too, weaving intricate paths that intersect and diverge according to celestial mathematics. Into this grand mechanism comes a rare interruption, two visitors whose paths, though different in every way, bring them toward the same stage at almost the same moment. One is 3I Atlas, rushing inward on a hyperbolic course from far beyond our solar system. Its inclination is nearly 175 degrees retrograde, meaning it swims against the current of the planets, like a salmon ascending a cosmic stream. It approaches from beneath the plane of the solar system, cutting upward across the orbits of worlds. Its very trajectory tells us it does not belong here. It will not stay. After its close pass by the Sun, it will depart, vanishing into interstellar darkness. The other is Swan R2, an entirely different kind of traveler. Born of our own Oort cloud, the icy shell of comets that surrounds the solar system like a distant halo, it follows an elongated ellipse. Its orbit stretches for centuries, carrying it into the frozen outer reaches before gravity pulls it inward again. Swan R2 is no stranger to the Sun's warmth. It was shaped by it, awakened by it. Unlike 3I Atlas, Swan R2 belongs to this system. And yet, by chance, or by something more, both comets find themselves converging here in October of 2025. The mathematics of such timing astonish astronomers. Billions of comets exist in the galaxy. Interstellar wanderers like Atlas are incredibly rare. Long-period comets like Swan R2 visit only occasionally. For two such objects, one interstellar One local to reach their perihelia within weeks of each other feels almost absurdly unlikely. The odds suggest it should happen once in millions of years. And yet, here at Island, two paths written across cosmic time, intersecting within the span of a single human season. Imagine watching from Earth's surface. Each night, as October deepens, you might lift your eyes to the sky after sunset. Swan R2 dominates, a sweeping, brilliant brushstroke arcing above the western horizon. Its tail stretches for millions of kilometers, visible even through simple binoculars. Atlas is fainter, subtler, requiring patience and a telescope, but unmistakable once found its green hue, glowing like a lantern in the dark. One grand and flamboyant, one delicate and precise, the two share the same canvas of sky. Astronomers sometimes speak of resonance when describing orbital patterns. Moons resonate with planets, planets resonate with one another. But the resonance here is not gravitational, it is poetic. Two stories unfolding at once, two instruments in a symphony, joining for a brief harmony. Swan R2 shines like the sweeping strings of an orchestra, full and resonant. Atlas sings like a flute, high and piercing, subtle but unforgettable. Together, their music fills the night, for those who choose to listen. Mars, too, plays its part. On October 3rd, the red planet drifts close to 3 I-Atlas within 30 million kilometers. For our robotic emissaries orbiting Mars, it is a front-row seat. Cameras and spectrometers turn toward the visitor, gathering data that Earth cannot. For a few days, Mars becomes our cosmic outpost, bearing witness to the Green Wanderer's passage. Imagine those machines silent, steady, orbiting far above Martian deserts, recording photons that left the comet's coma only moments before. From the stillness of Mars, they join Earth's telescopes in listening to the same story told across space. Swan R2's timeline is different. The other arises from the Oort cloud, that distant shell of icy bodies encasing our solar system like a frozen halo. Their home origins could not be more different, yet here they are, approaching the Sun at nearly the same moment in human history. It is a convergence so rare that probability suggests it should occur only once every few million years. And still, in this particular October, they share the sky. Its perihelion came earlier, in September, when it swept to within half an astronomical unit of the Sunday. Its closest approach to Earth comes later, on October 20, first only 0.27 astronomical units away, closer than Mercury or Venus ever come. In cosmic terms, that is nearly brushing past our doorstep. For backyard astronomers, it is a gift. For professional observatories, it is a challenge and an opportunity time to measure, to analyze, to capture details before the comet fades again into distance. And then there is the silence to come. As both comets approach their brightest, they also approach the blinding glare of the Sunday. For weeks, possibly months, they will slip from our sight. Ground-based telescopes will go blind, coronagraphs will saturate, and the instruments will fall silent just when the comets are most alive. What unfolds during those hidden weeks' outbursts, fragmentations, or perhaps nothing unusual at all will remain unseen. When they re-emerge, we will study their scars, their brightness, their colors, and try to reconstruct what happened behind the curtain of light. This timing, this silence, adds another layer to the dance. It is as if the universe invites us to watch the beginning and the aftermath, but not the climax. Like a play where the central act is hidden, leaving the audience to imagine what took place off stage. For scientists, this is frustrating. For dreamers, it is fuel for wonder. What if the unseen holds secrets beyond our models? What if these visitors carry messages we are not yet meant to read? Myth has always spoken of such convergences. Ancient cultures read comets as omens. as heralds of transformation. The sudden appearance of a bright comet often coincided with the rise or fall of kings, the birth of prophets, the shifting of ages. In that sense, the October pairing of Atlas and Swan R2 feels archetypal, two lights arriving together, like signs written across the heavens, one sharp and foreign, one vast and familiar, meeting in the glare of our star. Whether you see coincidence or choreography, the symbolism is powerful, and perhaps that is the true beauty of this cosmic duet. It reminds us that the universe does not revolve around human meaning, and yet it still leaves room for our imagination. The paths of these comets were traced long before human eyes ever opened to the sky, and yet they converge here, now, when we are able to notice, to measure, to wonder. It is not that the cosmos bends toward us, but that we are awake enough to see it. So, as you close your eyes tonight, let yourself drift into that dance. Picture the solar system's vast clockwork turning, the planets circling, and two travelers weaving across its gears. One comes from beyond the stars, the other from the frozen edge of our own home. Their paths are different, their origins worlds apart, and yet, for this brief season, they dance together under the light of our Sunday. Human beings are pattern-seeking creatures. When we look into the sky and see two rare comets arriving almost together, our minds cannot resist weaving stories. We are not content with coincidence. We search for purpose, for design, for hidden meaning behind the cold mechanics of orbit and gravity. And so, alongside the careful notes of scientists, a web of theories begins to form. Some are cautious, some wild, some poetic. Each reflects not only the comets themselves, but the hearts of those who imagine them. One theory whispers of the scout and the fortress. In this story, 3IATLAS is the scout, small, swift, deliberate. Like an advanced reconnaissance probe, it sweeps ahead, measuring the solar system, tasting its chemistry, recording its strengths and vulnerabilities. Swan R2, far larger and more spectacular, plays the role of fortress. It is imagined as a mobile base, an outpost, perhaps a communications hub disguised as a comet. Their timing is not chance, but coordination. The scout arrives first, mapping the terrain. The fortress follows, ready to establish presence. To those who dream this theory, October 2025 is not a coincidence but a strategy. Another theory paints them as an ancient patrol. Perhaps, long ago, a civilization seeded the galaxy with automated monitors. These machines, hidden in natural-looking bodies, lie dormant for millennia. When signs of intelligence flare radio waves, industrial emissions, they awaken. Humanity's century of broadcasting might have triggered their return. In this vision, Atlas and Swan R2 are not strangers, but guardians, checking on a young species learning to speak across the void. Are we dangerous? Are we ready? The comets glide in silently, assessing, recording, perhaps even sending reports back into the dark. Astronomers, who spend their nights surrounded by screens and humming machines, know the odds well. They lean over glowing monitors, reviewing streams of numbers pouring in from observatories across the globe. These numbers tell of positions, brightness curves, and spectral signatures. Each one is a clue, like the heartbeat of a distant traveler carried across light years. Others imagine something even stranger, a reply. For decades, our world has leaked radio and television into space. An expanding bubble of electromagnetic chatter now reaching nearly 100 light years. What if, somewhere within that sphere, someone listened, howled? What if they chose to respond, not with signals, but with presence? In this story, Atlas and Swan R2 are messengers. They are the physical reply to a message we never meant to send. their journeys timed to arrive during our technological age. Seen this way, October's convergence is not random at all. It is an answer. Some theories take a different turn, suggesting the visitors are not alien at all, but echoes of ourselves. Imagine that in some distant future, humanity masters interstellar travel. Imagine our descendants launch probes backward through time, or along trajectories so carefully calculated that they arrive during our age. These comets, with their strange chemistry, could be artifacts of our own making technologies meant to signal across epochs, leaving messages for our younger selves. It is a dizzying thought that what appears as cometary outgassing could be the exhaust of machines built by a future humanity we cannot yet imagine. Others, still, see myth where science sees orbits. For ancient cultures, comets were omens. They heralded change, empires rising or falling, prophecies beginning, ages ending. In that archetypal framework, the double arrival of Atlas and Swan R2 feels like a cosmic punctuation mark, two lights in the sky, written like verses in a poem, separating one era of humanity from the next. Perhaps they symbolize transition, not in science, but in story. And sometimes, stories carry truth in ways numbers cannot. Of course, within the web of theories lurks the darker imagination. The predator and guardian hypothesis suggests one comet may be a weapon, the other a shield. If Atlas is a scout with ominous purpose, Swan R2 might be a protector, dispatched to neutralize it. Or perhaps the reverse is true: Swan R2, the consuming fortress, Atlas, the warning beacon. Their meeting could be a confrontation written across the solar system, with Earth an unwitting bystander. It is not hard to see why such narratives thrive. Conflict is a familiar lens, even when projected onto the stars. Scientists, naturally, remind us to be cautious. The absence of iron, the abundance of carbon dioxide, the strange timing, all of these anomalies can be explained by natural processes, by chemistry and statistics. Theories of probes and fortresses are not supported by evidence. And yet, even the most cautious astronomers admit anomalies matter. Science grows by studying the unexpected, by asking questions that feel uncomfortable. To dismiss anomalies outright would be to silence the very whispers that lead to discovery. The Harvard astronomer Avi Loeb, known for his provocative suggestion that Oumuamua might have been artificial, has pointed to Atlas with similar curiosity. He reminds us that extraordinary evidence deserves extraordinary consideration, even if it risks ridicule. Others reply that speculation is healthy, but data must lead. The dance between skepticism and wonder, between caution and imagination, is as old as science itself. You might wonder, lying in bed tonight, what story feels most true to you? Do you imagine scouts and fortresses, patrolling civilizations and hidden messages? Or do you find comfort in the simplicity of natural beauty, two icy travelers meeting by chance? Nothing more. Perhaps the truth is both stranger and simpler than we imagine. In the end, the theories say as much about us as they do about the comets. We tell stories because we crave meaning. When faced with coincidence, we invent choreography. When faced with silence, we fill it with voices. The scout and fortress, the ancient patrol, the cosmic reply, each is a mirror reflecting our hopes, our fears, our longing to know we are not alone. And so, October 2025 becomes not only a month of astronomy, but a month of imagination. Two comets blaze across the sky, and humanity spins 1,000 stories beneath them. The data is precise, the measurements exact, but the theories are human, woven from wonder. Ground stations relay them in data streams, digital rivers flowing toward analysis centers where human minds labor to make sense of what their machines have captured. And yet, beyond all the measurements, there is still the unshakable feeling that something extraordinary is happening. If you imagine space as a great ocean, 3I Atlas is a shell, carried here by waves, from a distant, unknown shore. It is only the third confirmed interstellar visitor humanity has ever seen. Perhaps, as you drift to sleep, you can let both live together, the facts and the fables, the nickel and the myth, the trajectory and the dream. For in the end, the universe does not forbid us from wondering. It only asks that we keep listening, keep watching, keep telling stories, even when the truth is still hidden in the glare of the Sunday. Every story of discovery begins with a moment so small it could almost be overlooked. For 3I Atlas, that moment was a single pixel flickering on a screen in the Atacama Desert. On July 1st, 2025, in the dry air of northern Chile, the Atlas Survey telescope opened its mechanical eyelids to the night. It swept across the sky, as it always did, recording star fields with calm, mechanical patience. Millions of dots of light, unchanged for millennia, filled its detectors. And then, tucked among them, was something different, a faint smudge, a point of light that moved when everything else stayed still. To the untrained eye, it would have meant nothing, just a glitch, a speck of dust, a wandering pixel. But to the algorithms that compared each night's sky against catalogues of known stars and asteroids, it was a difference that demanded attention. The point did not follow the paths expected of ordinary solar system objects. Within hours, orbital calculations revealed a stunning truth: this newcomer was traveling on a hyperbolic trajectory, a path that could not be bound by the Sunday. It was not from here. It was from somewhere else, an interstellar visitor. Imagine the scientists that night, staring at their screens in Chile, Hawaii, or distant offices around the world. They would not have cheered loudly or danced in triumph. Astronomy rarely gives such theatrical moments. Instead, they leaned in closer, checked the data twice, whispered to colleagues. In the quiet glow of computer monitors, a sense of awe settled in. This was only the third time in human history that we had caught sight of a visitor from another star. First came Oumuamua in 2017, then Borisov in 2019, and now Atlas, another wanderer, another messenger from beyond. The Atlas system, short for Asteroid Terrestrial Impact Last Alert System, was designed for protection, to spot potentially hazardous objects before they could strike Earth. In a way, it is our cosmic alarm bell, always scanning, always alert. That this system, meant to guard us, would instead uncover a treasure of interstellar science feels poetic. It is as if a watchman expecting danger instead encountered wonder. The first pixel was not a warning, but an invitation. Atlas's trajectory told its story with elegant clarity. An inclination of 175 degrees relative to the ecliptic plane, meaning it came from underneath, traveling in retrograde to the planets. Its course was not an ellipse that would carry it back around, but a hyperbola, destined to swing past once and then vanish forever into interstellar night. The numbers, cold and precise, described a journey of millions of years across the gulfs between stars, now intersecting briefly with our small solar system. Imagine the comet itself, silent, dark, frozen. For perhaps hundreds of millions of years, it drifted in the void, its ices locked, its metals cold. It may have circled another star long ago, or perhaps was ejected from a newborn system during the violent shuffling of planets. For ages, it wandered nameless and unseen. And then, in July of 2025, a faint smudge on a CCD sensor gave it a name, 3I-ATLAS, the third interstellar object ever discovered, found by Atlas's patient watch. Astronomers rushed to measure it. The Hubble Space Telescope swung its eye toward the visitor, estimating its nucleus to be a few kilometers, across enough to generate the faint coma of gas and dust already streaming outward. The James Webb Space Telescope followed, revealing infrared signatures of carbon dioxide but little water. The Very Large Telescope in Chile added its own piece of the puzzle: nickel without iron, an anomaly that defied expectations. Each instrument contributed like musicians in an orchestra, each playing their part in the cosmic symphony begun by a single pixel. Yet the beauty of discovery is not only in the data, it is also in the human imagination that surrounds it. Its path is not bound by the sun. It dives in on a hyperbolic trajectory, destined to pass by once and then vanish into the cosmic dark forever. Swan R2, by contrast, is like a whale surfacing from the depths of our own waters, a body that has slumbered for centuries in cold obscurity, now awakened by the sun's warmth and blazing with reflected fire. One is fleeting, never to return. The other may wander away for eons, but remains part of the family of this solar system. Picture the Atacama Desert, where the discovery began: endless sands, wind whispering across dry stones, stars burning overhead in the clearest skies on Earth. Within that stillness, a telescope waits, humming faintly, its dome turning with the motion of the heavens. And deep inside, a sensor catches a photon that has traveled millions of years, bouncing at last into human awareness. That photon, so small, carried the signature of an entire world of ice and metal, a traveler from far beyond. There is a humility in such moments. Our instruments are fragile, our calculations imperfect, yet somehow we caught it. Out of the endless tide of objects sweeping invisibly across the galaxy, we noticed one and gave it a place in our story. How many others have passed unnoticed? How many interstellar wanderers have swept silently through the solar system without ever crossing a detector's gaze? Perhaps dozens, perhaps hundreds, each one carrying secrets we will never read. 3i Atlas is a reminder not only of what we know, but of what we miss. Astronomers often speak of detection efficiency. For every object we find, countless others slip by undetected, too faint, too distant, or hidden in the sun's glare. This thought adds weight to Atlas's discovery. It was not inevitable. It was luck, timing, persistence. The first pixel might so easily have gone unnoticed, dismissed as noise. Instead, it became a doorway. For months after its discovery, telescopes around the world coordinated observations. As Earth rotated, the comet passed from Chile to Hawaii to the Canary Islands, a baton handed across hemispheres. Data flowed across continents, into servers, into simulations, into papers written late at night by weary but exhilarated scientists. Each measurement refined its path. Each observation sharpened our sense of its nature. The faint smudge became a character, a story, a presence in our collective imagination. You can imagine yourself as part of that story. Imagine sitting at the console of a telescope in the desert, the cold wind brushing your face, screens glowing with fresh images of the sky. Imagine spotting a smudge moving against the stillness of the stars. You do not know yet what it island. You only know it does not belong. And slowly, through calculations and confirmations, the truth arrives. You have glimpsed a visitor from another star system, a messenger that has traveled for ages, only to appear in your watch. That is the power of the first pixel. It seems so small, so insignificant, but it carries a universe of meaning. From one faint dot of light, we learn of journeys across interstellar space, of chemistry that defies our rules, of the possibility that we are not alone. It is humbling, and it is beautiful. So, as you drift toward rest tonight, let your thoughts soften around that pixel. See it glowing faintly on a screen, just one dot among millions. Yet within it lies a whole world, a traveler, a mystery, a reminder that even the smallest signs can open the widest doors. and that sometimes the universe reveals its wonders not with thunder, but with the quietest whisper of light. Every comet wears a color, a quiet signature painted by sunlight upon its ices. Some appear white or gray, a faint dust haze against the stars. Others glow with bluish tails, ionized gases swept by the solar wind. But 3I Atlas carries a hue that has captured the imagination of astronomers and dreamers alike, a subtle but unmistakable green glow. From the moment telescopes recorded its coma, that emerald tint stood out. Faint through binoculars, vivid in long exposures, it shimmered like a lantern hung in the night. The color was not random. It came from chemistry. Molecules trapped for millions of years in deep cold had awakened as the comet neared the sun, their frozen bonds broken, their energy released in the form of light. Most comets show this, but Atlas did so with unusual consistency, as though the green were not an accent, but the very heart of its story. Scientists quickly pointed to familiar culprits. Diatomic carbon, two carbon atoms bound together, often fluoresces green when struck by ultraviolet light. Cyanogen, a compound of carbon and nitrogen, can do the same, its faintly toxic signature glowing with ethereal beauty in the vacuum of space. Yet in Atlas, the intensity and stability of the green puzzled experts. It was too persistent, too uniform. Usually, cometary colors shift as different ices sublimate first carbon monoxide, then water, then dust. But here, the green remained, steady as a heartbeat. Imagine yourself watching it through a telescope on a still October night.